All right, this right here is a pretty interesting application of calculus. So you've got the ground right here, and then there's a building. Nice building. 27 feet away, there is an 8-foot wall. So this wall is 27 feet away from the building. The wall is 8 feet tall. And then there's somebody that's trying to break into the building, so they're going to take a ladder and put it straight across like this, and then climb up and get into the building. But of course, they want to bring the smallest ladder possible, so we need to use calculus to help them do that. So L is going to be the length of the ladder. This length right here, where the ladder hits the ground, how far away from the wall, that's not known, so I'll call it X. And this height, where the ladder reaches the building, that's not known, so I'll use H. Now, one thing to do is set up some equations. So if you look at this little triangle right there, it's a right triangle. And its height is 8, and the base is X. And now if you look at this whole right triangle, then it's basically just a bigger version of the triangle that I just drew. And its height is H, and its base is X plus 27. And then we could set up a proportion. So that would be like H compared to 8. So H over 8. So I did the right side compared to the right side equals the bottom compared to the bottom. And then we just need to solve for H. So multiply both sides by this 8. And H is equal to 8 times an X plus 27 in parentheses. The whole thing is divided by X. So this is the auxiliary equation. We're going to pause on that and then find out an equation that involves L. Because right now I don't have anything about the length. So this is going to be the main equation. And for that, just use the Pythagorean Theorem. So L squared equals H squared plus X plus 27 squared. And then over here, we already did the work to solve for H. So just take that and substitute it in for H right here. So it needs to be squared. So I'm going to go ahead and square the 8 is a 64. And then it would have parentheses X plus 27 is squared. And on the bottom, it would have X squared. And in order to find the minimum, we'll take the derivative and set it equal to 0. But before doing that, I noticed that this has X plus 27 squared, and it's also here. So I could actually factor that out, and that's going to save me a little bit of work later on. So if you factor this out, what's left is 64 over X squared. And then plus a 1. Now I think I'm ready to take the derivative. Well, on the left-hand side, when you take the derivative will be 2 times L, and then because of the chain rule, times L prime. On this side, I need to use the product rule. So this is a product. Take the derivative of the first thing, which is going to be 2 times X plus 27. Subtract 1 from the exponent. And with the chain rule, the derivative would be 1, so multiply by 1. Now I'll leave this one alone, 64 over X squared. And then plus, leave x plus 27 squared alone, and then take the derivative of this. Well, this is like having 64, can you see my scratch paper? 64x to the negative 2. So if you take the derivative of that, bring the negative 2 in front and multiply, that's going to be negative 128, and then subtract 1 from the exponent, it's going to be like that. Or in other words, its derivative is negative 128 over x is cubed. And the derivative of 1 is 0, so that means I'm done taking the derivative. Now, set the derivative equal to 0. So this L prime equals 0, which means it's going to be 2 times L times 0, so that's just 0. And then I can factor, because this has x plus 27 and this has x plus 27. Also, I could factor a 2 out, because I could factor a 2 out of this 128. So I'm going to factor out a 2 and an x plus 27, which means all of this is gone, so it just leaves this part. 64 over x squared plus 1. And one of these got factored out, but one remains. So plus a single x plus 27 that's being multiplied with. Now with this, I factored a 2 out, so that's going to leave negative 64 over x cubed. And you might be thinking, oh my gosh, this is not going to work out. But believe me, it is going to work out. Now, since we already factored, you could set this equal to 0, but then that would say that x equals a negative 27. And if x is a negative 27, together with that positive 27, it means this wall is actually part of the building. But it's saying that it's away from the building, so that's not possible. So really, we just need to take this part and then set that equal to 0. So there's a 64 over x squared plus 1. And then I should go ahead and distribute this. So that would leave negative 64. And when you multiply this and this, one of these x's is going to get canceled. So now it's over x squared. And then minus 27 times 64 over x cubed. And then it just so happens that this, oh, I forgot to say, I set it equal to 0. Just so happens that this and this are going to cancel each other out. So all that's left is the 1 and this term right here. So for that, I need a new piece of paper. So these two cancel. All that's left is the 1 minus 27 times 64 divided by x cubed. Usually I would multiply this out, but I can see that at the end I'm going to have to cube root it, and I know how to cube root each one of those numbers, so I'm just going to leave it like that. So move this to the left side, it becomes a positive 27 times 64 over x cubed equals a 1. Then multiply both sides by x cubed. And now all we need to do is cube root both sides. See, I told you it was going to work out. The cube root of 27, that's 3. The cube root of 64, that's 4. So even though it looks scary for a little while, it turns out that it's not. X is equal to 12 feet. We're almost done. Now we can take that number, plug it in here, and find out what h equals. And then we could take those two numbers, plug it in over here, and finally find out how long is the beam or the ladder. So next, h is equal to 8 times x plus 27, so that's 12 plus 27, and then divided by x. So 8 times 12 plus 27 divided by 12 works out nice, that h is equal to 26 feet. So the ladder would reach 26 feet off the ground. And then finally, substitute those numbers into the Pythagorean theorem. So L squared equals h squared plus x plus 27 squared. So I'm just going back to this equation right here and then substituting what we got for h and what we got for x. And then to solve for L, take the square root. How much is a 12 and a 27? That's 39. So how much is the square root of a 26 squared plus a 39 squared? So the beam is going to have to be 46.872 feet long.